Okay, the next little bit is on finding the inverse of a 2 by 2 matrix. So to find the inverse of a 2 by 2 matrix, you can find the inverse of any non-singular matrix. So if a matrix is singular, it doesn't have an inverse. So that's the first most important thing. It has to be a non-singular matrix. And what we mean by inverse is kind of the opposite. So we discussed inverses. We've done it way back. So if you had an equation to solve x plus 5 equals 7, you do the inverse of plussing 5 to both sides. So you minus 5 to both sides to get rid of it. So that's exactly the same. We do the same with functions, inverse functions, the notation for inverse functions. And we do the same with sine, cosine, inverse of those. And the inverse notation, so the inverse of a matrix, if I say this matrix is M, the inverse of the matrix M is the matrix M minus 1. And this inverse has the property that if you do any matrix times by its inverse, that will be the same as the inverse times by the matrix. So it doesn't matter what order you multiply them in. Remember, sometimes with matrices it did matter which order you multiplied them in, but for an inverse it didn't matter which order you multiplied them in. And that will always equal the identity matrix. You should have watched a video of what that was. It was the matrix where the diagonals are 1 and everything else is going to be 0. And there is a formula for finding the inverse matrix. And the inverse matrix is found by, if M is the matrix A, B, C, and D, then your inverse matrix, M minus 1, we find by doing 1 over the determinant of matrix M, and that was the determinant of this matrix, which was A, D minus B, C, and then the matrix has the A and D places swap over, so that goes like that, and then B and C both become negative.